we will move to the last presentation of the first session. You heard, we have guests from Miskolc, Hungary, and we will hear about the lithium and other critical raw materials related projects in the University of Miskolc.
Thank you very much. So, ladies and gentlemen, my name is Norbert Nemeth. I'm a geologist from the University of Miskolc, Faculty for Earth Sciences and Engineering, Institute of Mineralogy and Geology. And let's step back now from the working technologies to the geological probabilities. I will talk about the three major projects which were conducted by our university, of course with partners, which are related to our topic, lithium, but also to other critical raw materials. And I will also mention an additional, bit older, research and development tasks and its results, which are also important for our topic. And I will also talk a bit about the lithium potential of Hungary in the light of all of these results. So the first, which I should mention, is the critical project, which was made from the first half of the, made in the first half of the previous decade. It was targeted mainly on the assessment of the critical raw material potential of Hungary, based on the first list of the CRM of the European Union. This project was targeted mainly on hard rocks, so on ores practically, but also we collected all archive data which are related to any potentially useful materials and ores. Here you can see in that map which were our main targets, which kind of critical raw materials, critical metals were known as indications or deposits in Hungary already. But we not only collected archive data, but also made new analysis, new sampling and analysis regarding these ore bodies and occurrences. And these results were published in 9 monographies with an additional one, because the 9 monographies were provided in Hungarian only, but there is an additional volume in English summarizing everything. This can be accessed freely on the homepage of the project still. Well, new lithium results from these projects were not provided for 2 reasons. One thing is the lithium was not listed as a critical raw material in that first version of that European list. And the second reason is an analytical one. The trace element analysis is made by inductively coupled plasma, either atomic absorption spectrometry or mass spectrometry, but the processing of the samples happens with a lithium borate fusion. In consequence, all trace elements can be analyzed well, but not the lithium, because it is in the pre-treatment added. So lithium analysis should be made separately, of course. But archive data also contained some lithium. And there are some additional data coming from that older task, which was made 20 years earlier. It was a task assignment from the Hungarian Geological Institute to our institute, and the wells that could be sampled and assessed in that time were analyzed by atomic absorption analysis. More than 1,000 water samples were processed in that way, and more than 800 samples contained also lithium data. Of course, most of these data show negligible lithium content, but a small fraction is quite good, so over 10 ppm. We have also about 19 samples in that data set. So that covers almost all Hungary. it includes drill hole samples, but also springs and such surface samples too, and not only thermal brines, of course, but all kinds of brines are included in that. So from all of this data collected, and also from the published data, we have a picture about the potential lithium resources in Hungary. Well, firstly, the hard rock possibilities. The most common type of hard rock lithium deposits is attached to granitic bodies, the pegmatitic alteration of these granitic bodies. So granitic bodies are on the surface in Hungary. There are three major occurrences, including also gneisses, in the Sopron Mountains, in the Velence Mountains, and in the Móraj Hills in the south. But also, these granitic bodies occur in deeply covered position under the recent young sediments of the Pannonian Basin. These depths might mean several kilometers, and it is reached by some deep drill holes. Where granitic bodies were also analyzed as hard rocks. We have the data provided for the Velence granite. As you see, the concentrations are not very high. Well, it would be high if it would be milligram per liter, but in a hard rock it is not a very very large value, so it is in the range of the typical granites on average. The other type of hard rock deposits are those which are related to clays and which are coming mostly from the weathering of acidic volcanics, so the volcanic counterparts of the granite, rhyolitic volcanics. Such deposits are not so very large and not so very widely distributed. In our country, such deposits could be also expected, and there is one type of deposits, or I shouldn't say type because it is a unique case. South from Hungary, you might have heard from that jadarite in Serbia, which is related to an intramontane basin from the early Miocene filling, which also comes from the weathering of rhyolitic tuffs. So such basins we also have in Hungary, for example, the North Hungarian coal basin, but unfortunately the analysis of the coal ashes are not very promising in that region, so it is not very promising, but the cover of the Pannonian Basin still can hide several things from us, so even that jadarite might be not a single example in that case. And another thing which can be mentioned as potential for lithium are the manganese and bauxite deposits, mostly in the Transdanubian range. This can be important because manganese can absorb lithium or include lithium in the lithiophorid manganese mineral, and also that mineral is related to bauxite deposits mostly. Well, these resources are not very potential again because these are either exhausted or the mining is stopped recently. So mining wastes and secondary products or processing wastes can be potential for that, but that's beyond our topic now. But there are also the lithium-rich brines. Those points which are indicated with yellow stars are those drill holes and wells where the highest lithium values were measured in our data set. These values might reach the 50 ppm, but are mostly lower than 50 ppm, still higher than 10 ppm. So in that range which was showed before in the previous presentations as a lower limit of the possible extraction. So far for the potential of Hungary. And one thing to mention, of course, this data set doesn't mean that there are not better data. We have several hydrocarbon drillings, which also resulted brines, and I'm sure that the oil companies, mainly the big Hungarian oil company, has more data, which are not accessible for us, but recently they presented a case not mentioning the exact position, but somewhere in the south of the Great Hungarian Plain, where there is a quite high, more than 200 milligram per liter content in a brain, lithium content in a brain, and they plan to work with that toward the lithium extraction. But that's not our business, as I said. So the next project, which I should mention, is that CHPM project. The idea of this was to utilize secondarily those fluids which are used in deep geothermal projects. The main thing is in such project that water is pumped from the surface in very big depths, so meaning several kilometer depths. So this works not with natural brines, but this water will leach surely something from the rocks when coming again to the surface, and this something can be precipitating and can be extracted also if the technology is provided for that, so that consortium worked for that technology. Anyway, such projects are not very widely distributed in Europe because of environmental restrictions and issues, but there is at least one working project which you might have heard of, that for a geothermal plant in France, in the Rhine-Graben, where lithium extraction is an ongoing thing already, but that's not our project. It was another project which achieved that thing. So the targets of these projects were assessed from our institute, so we were involved in that project in the part of the geology to find the potential sites for such extractions. I can again emphasize that it's not only for lithium, but for all kind of useful materials, useful ore, and useful metals which can be extracted. Anyway, an important type of targets are the granitic bodies and the pegmatitic bodies also, because these also contain high amounts of radioactive elements and radioactive heat production, relatively high amounts. So these pegmatitic type of lithium deposits can be also achieved in that way, and then lithium can be solved and lithium can be discovered to the surface. The technology for that was worked out by this project. Several promising technological results were made by our partners, which can be found again in the deliverables, which can be freely accessed on the web page of that project. So that project was finished in 2019 with no working example. As I said, in Europe it is not possible at this moment to make new achievements, but still everything is ready to apply the results. And finally, the third project which is important for us was the Reflect project. This should be finished in this year. The closing event will happen just now in October. but already there is a continuation of the project, this CRM, Geothermal. So this is an ongoing thing where our university, not directly our institute, but another institute of our faculty is involved. And in that project, as you see again, a European Union-funded project, it is with several partners from several parts of Europe. Kind of important task was for us important task was to collect several data of the geothermal price, making the so-called European Fluid Atlas. This Fluid Atlas covers these colored countries of the European Union, including also Great Britain, which is not a member of the European Union anymore, but at the start it was included. And here you see how much data, fluid sample data, were collected. Of course, sorry for the small letters, the red columns are the interesting because that symbolizes the number of the fluid samples. But even in that database, the geochemical analysis of the fluid samples are very scarce, and lithium data are often missing from these data. So it is a trait that available data are restricted, and mostly, again, the best concentration data will not be included in such databases. For example, in Hungary, from the almost 500 fluid samples which were included in that atlas, only 35 of the records contains lithium concentrations. So that's what we are working on related to our lithium topic now. So thank you for your attention.
Thank you very much. Is there any question from the audience? We have time, so feel free to ask. So maybe one question from me. I want to ask you about the second project. What was the depth, the aimed depth?
About 5 kilometers. It depends on the heat flow conditions, of course.
And what was the temperature at 5 kilometers?
Well, it's not a special place, but the target is at least 300 centigrades. Comes up, of course, it will be cooler.
Okay, thank you. So, thank you for the presentation. Thank you for the first session.